Okay, so this is the dipole signal gantry that we're going to be using. You could probably use pretty much any signal gantry that you wanted to, or you could scratch build your own. I'm going with this one because I know that it's best for, at least in my case, it's best really good for 3 tracks that will be running through it. And so I've already put this on the layout, and I know that I need one signal right on the inside here, and one signal on the inside there, and another signal on the inside there. Actually, this one's right around the middle, so it's going to be a little bit off to the side just to make sure that I can get the signal lights through correctly. And what I went with was this little batch from Amazon. Amazon in the US, so I'll put a link to it anyway, but essentially it is 12 sets of these little 3D printed signal heads. I looked at making up my own and 3D printing it. I did actually go ahead and get all the dimensions for real from one of the manufacturers that does signal lights back in the UK. Again, I'll try and put a link up to it. It was pretty cool in that they had all the different dimensions that they needed. But for what it would then cost me to print these out myself, go and get the LEDs, I think I got a set of these 12 3D printed signal lights and red and green LEDs and the resistors for something like 10 US dollars, which is about 7 UK pounds. So honestly, I couldn't make these and get the LEDs for that kind of price. And all I'm going to do is push in a red and a green LED like that, push them all away, and just kind of hold them. I mean, they're pretty tight fit. They'll hold themselves in place. I'll trim those right around where they're crimped. I can try and zoom in. Maybe not. No. Not quite going to focus in. But there's a crimp mark right around on them. So I'm going to trim them to around about there. And then I'm going to use a bunch of 2-pair wire. So I have got some actual 30 and 32 gauge wire, which I'm pretty sure is what this equates to, but the coating on this is a little bit thinner, so I'm probably going to go with that, wire them on, and then figure out how we can route them down around the outside of those supports, try and bring them down the side, and then we'll drill a hole in the base. This is probably going to be the hardest part, is figuring out how to kind of hide those. What I'll probably end up doing is painting them black. It'll probably be a lot easier to paint them black ahead of time. So what I'll probably do is wire the 3 signal lights in, get them in place, and then figure out how much cable length I'm going to need to then run down. Probably paint them black quick with some acrylic paint, let them dry, rather than trying to paint it when it's already in here. I think I'll end up just making a little bit of a mess. So paint them black for whatever it is that I need, and then I can kind of route the cables back through, glue the signals in place, and that should pretty much be good to go. Okay, this is the first one of those done. It's not the super cleanest of jobs, but they're all fairly nice and shiny. Probably came a little bit too far back, so I know for next time I don't need anywhere near that much exposed. I'll then get some heat shrink just to put around that. But in terms of what I use, people have asked me before, I use a soldering station. It's got adjustable controls on that. I have used cheapy irons for most of the time I was doing stuff. All of the switch paneling I did was done on a very, very cheap, $10. It was probably 20, 25 watt soldering iron. No kind of temperature control, big fat tip that was super duper dirty. And I found that having switched over to this makes the world of difference, being able to control the temperature. Also then use a Hako cleaning tip as well, so this is a little bit of a bigger tip on it than I would normally use. I couldn't find where the pencil tip is, but the idea is that you can change the tips that are on these as well. So this is more of a flat tip. You can get pointed tips, you can get larger, fatter tips, and so once you're done, you then just very quickly run in and out of there to clean it up, and that's it. It does still have the wet sponge as well, so you can then clean up after that. So that's the cleaning tip. I use a solder pen. I do have, a flux pen. I do have some actual flux as well, but for this stuff I find it easier, because I'm going to have to try and get some flux on the actual LED legs as well. I find a flux pen a little convenient. And then solder. This is what I've gone with for a while. It's electrical solder, so it's mixed silver, rose, and coal. I find that works pretty well, but honestly, most electrical solder, some kind of flux will work. The flux, again, kind of like with the adjustable soldering iron. Flux I'd used for a while, and that made a huge difference, and then stepping up to an adjustable solder iron. But you don't need super duper fancy, 100-pound soldering irons. I think this Welle unit was $35, $40 maybe, something like that. But it does make a world of a difference, and then something to hold them in as well. Color-wise for your wiring, come up with some kind of color convention that makes sense to you. It doesn't really matter what the colors are, but again, I found that it makes a big difference to have some kind of logic to your colors. So the way that I'm going to do it here is, the color will always be positive, the white is always going to be the negative, and then it should make it fairly easy for me to be able to track which one is which. I'm then just twisting both pairs together, and then on the end I'll just make a note as to which one it is. So I'm going to go ahead and put on some heat shrink on the end, and then we'll start to wind that through the signal gantry, figure out where it will be so that we could then paint it, the wiring, and then move on to the other two lights that are going to be needed. Yeah, so I really hadn't been a fan of that first one, so I went ahead and trimmed it back just a little bit further and took out another one. Trimmed the legs of the LEDs back just a little bit further, and then went in. And then rather than trying to heat shrink this, what I ended up using was something called liquid tape. This stuff stinks. It really does, and it's almost like the viscosity of oil. But our model railway club uses this a lot when splicing wires for bus wires and things like that. So it's fairly well used, works out pretty well. So yeah, that's kind of what I went with there, and then wrap these fairly tightly, just so that it forms somewhat of a decent cable almost, and so it's fairly rigid as well. It holds itself up in straight lines. The idea is that when that then sits inside the gantry, it should look like some kind of real cable trunking that will go through there. So I'll also go ahead and probably paint up in the back of there. You can see the red LED coming through just a little bit. So we'll go ahead and pin those up and get the other ones ready to go too. This is the three of them now all put together. I actually went a little bit more liberal on the liquid glue on the back of these. The idea is to try and basically fill them in. I don't know how well you can focus in on one of these, but it's fairly well filled in now. Basically just filled up that liquid tape to make, not airtight, but wouldn't want to dunk it in water or anything, but it is meant to be waterproof. But just to try and fill out the back of those. And then wanted to also show you essentially the breading of the cables. Like I said, just wrap them fairly tightly. I had tried on a first attempt, let's see if I can just pick up what one of those would have been. I had tried on a previous attempt just to kind of loosely wrap them together, and then my plan had been to wrap them in some kind of heat shrink or whatever to kind of see, but it was too big. It was taking up too much space when I then kind of dry fit it into the gantry. So this works out a lot better. Essentially you just hold it like that and then just twist around, and it ends up pretty good. So now that they're all put in place, it takes just a few minutes for that liquid plastic to dry up, and then we can start to feed those into the gantry, get them in place, and then start to get some trunking down the side of the gantry so that they'll look a little bit neater. Okay, so this is then those lights in place. And you can say because you had that kind of tight wrap, they don't blend in. There's also nowhere to completely hide them just because of the thickness at the end, because there's going to be three cables that end up routing through that, and that is kind of all the way through. But I'm going to try and put up a picture that I had found through Flickr. That gives an idea. It's kind of a long distance shot, so hopefully that's up on screen now, and what you can see if you look closely is the cables routing through them from each of those signal lights. So even on the prototype, and again the gantry isn't quite the same, but even on the prototype where you would have the gantry across the tracks, you can still see some of that cabling coming through, and that would make some amount of sense as well, because then on the back there where the workman would climb up and do some maintenance or do some repairs, they would need to be able to have access to that as well, so they wouldn't be completely kind of tucked away. From the rear, it doesn't look too bad. They're kind of hidden back behind some of the gantry work. That one on the left, not so much. Unfortunately, I had to go in and replace the red light. On that one, I got everything wired up and got everything run down, and that red light then wasn't wanting to play nicely when I was quick testing it, so I might need to try and push that down a little bit out the way. But otherwise, from the back, it wouldn't be that visible, so, if you were down kind of at track height, you wouldn't really be able to see it. And again, from the front, it's not too bad. Just ran them down the side loosely like that. I'm not sure if I'm going to try and build some kind of trunking to go around that. Again, when you're kind of at that front on profile or that kind of side on profile, it's not too bad. But yeah, I might look at trying building some kind of trunking to go in there. On the ends, I'd also then wired it up with these female jumpers. The idea is that they'll then just plug straight into the header pins. So now I'll switch over and look at some of the electronics that hopefully are going to make all of this work. Okay, so this might look like a little bit of a rat's nest of wiring just because of how I'm jumping it in, but this is one of those LED driver boards. So this is a 12-channel LED driver. So what we have is 6 channels on either side. So the 6 channels on the right, I'm using then 6 channels on the left. So it starts at this far end with channel 0, 1, 2, 3, 4, 5. It starts with 0, computer-based numbering, and then over here we've then got 7, 8, 9, 10, 11, 12. So the idea is that I am using the first 6 channels here. Try and rotate it around. So all I have done is then jump it in. So that's why I then put on those female jumper wires. So solder and then heat shrink all of what was coming in from those signal lights onto those female jumper wires, and it's super duper easy to plug those in. So in one of the earlier clips I had said it doesn't really matter what color you're using for your wiring, as long as you have some kind of convention that you can remember or you can keep track of. So again, that's why I was going with the solid color for the positive, and then the dash color, the white color, for the negative. So all of these pairs that come in, so if we come over here, green is positive, orange is positive, red is positive, green, blue, they're all positives, then the corresponding white pair is the negative, so that then makes it super duper easy to plug in. It's kind of hard to show on here, but it does show on the board, and it does show in the tutorials online how to wire these up. So the outside pin is positive, the inside pin is negative. Same over here, inside pin is negative, outside pin is then positive. And so and I appreciate that electronics might be a little bit scary for some people, but all you have to do is then put positive to the outside, negative to the inside, and go all the way down, and we should then have pretty lights like this. The best blue Peter here is one I made earlier. So this is now the one that's hooked up. Let's try and talk through what we're looking at. This would sit on the south side of the station, facing into the station. So as the trains would be heading southbound, they would come to this gantry. So on the left-hand side is what would essentially be that freight bypass line, where it comes in and then meets the southbound main line. On the right is then essentially the northbound line. So what we would have here, this is in its default state when the unit starts up. Southbound main has green, you can go. The northbound on the right is red, because actually coming north on that northbound main line would default to green. The reason why you have a light showing the south direction on that northbound main line, try and wrap your head around that. You can head south on the northbound line because right after there's a point. This will probably make a lot more sense when we actually see it dropped on the layout. But the DMUs that are on platforms 9, 10, 11, and 12, as they will be coming out of those platforms, they have to traverse the essentially northbound main line and then switch over a point. In real life, they could actually then swing west along the river and head out towards Hexham and stuff like that. I'm not modeling that just because of space constraints, but there is a reason why trains would be heading south on that northbound main, but the default action is that that light will be red. And then the same on the freight line. On the left-hand side, freight line by default, its default state would be red because their southbound main would have green. So I haven't got into any of the push buttons that would control routing of any of this. I haven't got any of the sensors that are controlling this yet. This is purely just to get the lights up and running. But one of the reasons why this is cool compared to one of the earlier videos that I had shown where I was trying to use shift registers is that it was still somewhat complicated to try and control the shift registers. This is an awful lot easier because it's a lot easier to try and figure out the addressing on these, not using resistors. These are pulse wave modulator, PWM, I think, so you can control the intensity of these lights. Best that I can tell, it's essentially being able to control the power output to them, so it's almost like putting a resistor in place. So I haven't found anything that says you need to put the resistors in front of the LEDs. You essentially control the intensity of the power going out to them. So this is actually pretty much their lowest intensity. They go up to 65,535. Computer numbering, don't worry, but I think these are at 1,000. So they probably look a little bit brighter actually on the camera than they are in real life. But yeah, I had to knock them right down. But anyway, this is the 12 channel driver, and all you have, I apologize if electrics are somewhat foreign to you, but I'm trying to walk through this the best I can. These then 5 pins on the end. The one on the right, black, is taking negative, the ground. The 2 to the left of that, the 2 red, are feeding positive power. There's actually only then 2 pins. There's a brown and an orange cable kind of hiding out. Try and trace these over to the Arduino. This is an Arduino Mega. It's just got an additional number of inputs than you might typically have seen if you've done something with Arduino. So there's our orange and yellow, orange and brown, whatever you would like. And that's it. It's 2 pins to control all of this. Now you're saying, okay, well, you're still only able to control 12 LEDs. Well, no. You can jumper these. You can daisy-chain these boards together. So there's 5 then pins here. They will then feed out over to another board, and then the second board again can then feed out and can feed out. I forget how many you can chain, 30 or 40 quite comfortably. I think it's really driven by what is the total power draw of the LEDs that you would have connected compared to are you using 5 volt, 3 volt in, or are you using some kind of secondary power adapter to run this. So you're really limited by what is the total power draw of all connected LEDs once they're turned on. So you can daisy chain a number of these boards together. You're still only needing 2 pins. Now I've got so many pins on here at the moment, it looks like, well, why would I want to do that? But remember, I have to still put in all of the push buttons to control routing in and out of the different platforms. I also need to connect in the photoresistor sensors. That would sit underneath the track. That would add some amount of automation to help trip some of these lights. So I really need to try and cut down to 2, 4, 6 maybe pins. So basically everything on the south side of the station I'm probably going to daisy chain together off that one LED driver board. On the north side of the station, I'll probably then have another driver board over there, run that back over 2 pins, just that I'm not running a lot of wiring backwards and forwards. So that's kind of my idea. But anyway, so this is the 12 channel driver. I do also have a 24 channel driver, just so you can get an idea what they look like in the default state. You don't get a lot of header pins. You really only get the header pins to be able to do the power and the clock and data in, and then the jumpers out. So you will need to order a bunch more header pins to be able to do all of the connections in from the actual LEDs themselves, but they're pretty cheap and cheerful. How much was this? This doesn't have a price on it. I think this 24 channel was about $14 or $15. And then I think that 12 was $9 or $10, something like that. So it's actually a pretty cheap way of being able to do it. I'll try and now switch over and do a little bit of screen sharing from the computer so that you can see some of the code again, just so that you get an idea as to what's happening. And I'll also then try and share that code on GitHub. It is going to be scoped pretty specific to what I'm doing here, but hopefully it'll help out some people. If you are somewhat electronically inclined and you do like tinkering around with an Arduino, it's really not that hard once you figure it out. There's just not a lot of really good examples, at least that I could find, to be able to show how to do this. There was some really cool ones if you had, multicolor RGB LEDs, so you could do like rainbow patterns and control things like that. If you just wanted to turn LED on and off, the addressing of the boards and the intensity of the lighting, I couldn't find a really straightforward example that will do that. So this is pretty close to what I was wanting. I do need to try and figure out buttons and resistors, but let's have a quick walkthrough of some of the code, and then we'll drop this on the layout, and hopefully it actually starts to look pretty good. This is then the quick Arduino code for the signal gantry. So this is importing the library for that 12 channel driver board. So this is a TLC 599711, sorry. I think the 24 channel is a little bit different, but the rest of the code remains the same. It's just different library that you have to pull in for it. I only have one of the boards at the moment. As I add in the additional boards, then I'll increase that to 2, 3, 4, and that's just in terms of how you would then come to address them. Data and clock, that's just the 2 pins on the Arduino that I have that connected to, so in my case that's 52 and 53. And then all we're doing here is saying, okay, we want to create a new instance of one of these LED driver boards. How many do we have? So I want to initialize the first one, and on the clock and data pins that we set. This is then getting into the power output for those channels. So I think it does go up to 65,535. I set it to 1,000 here. The reason I did it here is that if I want to change the intensity of those for whatever reason, I only have to change it in one place. It'll automatically update the rest of the way through. So now defining what channel each of the signals is connected to. So the way I've tried to do it here is comment it kind of for my own sanity in a way as well. So indicate which board it's connected to, which channel it's going to be connected to, the red and the green light, and then what is the color of wiring for each of those. Because we had then soldered on those female jumpers onto the end of each of the pairs of wires that were coming down, the colors don't match. And it's also then going to be kind of hard to try and trace those back to the gantry where it's above the layout. So I'm putting in the code here so that if I have to disconnect things for whatever reason, they've got real easy reference right here. And then I'm also then trying to call it something somewhat sensible. So fret south red, fret south green, so that's the fret bypass line. Southbound main, red and green. Northbound main, in a southerly direction, red and green. So the idea is that to be able to expand that out. So here you can see I've already added in the code for the south station signals for that northbound line. So at the moment I've just got a gantry, but I had alluded to in that last video, and we'll see in the next clip when it's on the layout, I am going to have at least one additional signal that I'm already working on for the northbound main line just before you would come to this gantry. And so I'm already going ahead and declaring again board 0, channel 6 and 7, and what I expect the color of that wiring to be. Coming down to the setup, so Arduino code is broken down into a setup and then at least one loop, and then typically you'll have multiple different functions. I don't have anything in here right now because all I'm doing is just setting this up. That's why I'm saying this is very bare bones. I don't have any of those photoresistor sensors or any of the push buttons to set the route. So everything is really just being done in this setup for right now. Startup serial connection, just that I have some kind of output as to what's happening. And then when to start my driver boards, the TLC. That's what we initialized up here. So I'll probably need to rename this as I add in additional boards just to make it easier. But for right now, I'm just going with that default name. So TLC begin, saying something to the serial monitor as to what I'm doing. Then all I'm going to do is go through each of my lines. So TLC, set power, northbound main, 0. And 0 is basically going to be off. And then so set power on the northbound main green line, and I want that to have maximum power. Okay, so these first two, and maybe sounds a little bit odd, but I'm trying to go through logically from kind of the very, very south side and work my way up. So these are the two that we haven't actually built yet. are the ones at the end I've initialized. So you don't get into the gantry lights until these ones right here. So board, set the power for fret bypass south red to maximum signal power, which is what we defined as 1000. And then we want to have the green light as 0. On our southbound main, set the power for the red to 0, set the power green to be maximum, so 1000. On that northbound main southerly one, we want to set that to turn the red on, and we want green to be 0, we don't want that to be set. Also then going out and just putting something on the serial monitor just let us know that we're doing it. The last thing you have to do is write. So to your board, so tlc.write. Whenever you've made any changes to these power settings, you have to then go out and do a write. You can chain all of these together. So here I'm essentially declaring what I want 8 of the different LEDs to be, and then I'll write that out at once. When I would move down in the loop, in this loop part, this is where we'll have things like probables, those shift registers that will be watching for the photoresistor sensors, watching for push buttons for the routing. This is probably where that loop code will be, and then functions for route trains from platform 9 or detect train on southbound main. So there'll be multiple different functions that will then come down after here. So I'll probably only end up having 2 signal lights probably that would change. Maybe said red is now going to be turned on, so got a max signal power. Green is then 0, and after each time of setting those, I have to go back and do right. So that's kind of all there is to it. The main part that I was trying to figure out, I couldn't get a good example on, was this. And really all it boils down to when you just want to turn an LED on and off is your board dot set power, which LED, essentially which channel. So you could just do channel 6. Here you could just say, okay, what's that going to be, channel 1, and then what your power is. I'm doing it naming based, so it's easy for me to look at and understand what's happening as I would expand further down. And that's kind of all there is to it. It'll get more complicated with photoresistor sensors and the push buttons, but we'll look at those probably in the next video once I get to do it. So now we can go and check out what this looks like when it's actually on the layout itself. Okay, so this is then the gantry in place. Not quite sure why the 2 reds look a little bit different on camera, but they do look the same red visually when you're just eyeballing it. A little weird given that they're both meant to be the exact same LEDs, but I think it looks pretty good just like that. It's not permanently attached in place. I'm probably going to cut a little way into some of the ballast that I've put down just so that I can rest in there. I think it ended up looking pretty good. Quite happy so far with how this goes. And so you can see that the cabling just kind of runs down into a hole there. Maybe fill that a little bit, but the idea is that I would like it so it could be taken off, although I'm not sure if I'm going to keep it that way, if I'm going to more permanently attach it. Underneath, all the cables are just kind of hanging. I'm not quite sure how well you'll be able to see it. That will be attached up more permanently once I'm comfortable with where it's going to be. And then the Arduino is just kind of resting on a box as well. But again, the idea is that these were really easy to then just feed down through that hole and then connect into those header pins. So as I add more signals in, so there's another signal that I'm building that's going to go around about here as well, and then I'm probably going to have another one here for as this fret bypass would come in. I think that's probably going to be it for the south side of the station. It would be a lot more complex than this in real life, but I think that's probably how I'm going to run just for now. So I've got some amount of operational interest and some amount of signaling without being a little bit overpowering, because then I've got to come and work on the signaling over on the actual platforms themselves, and they are going to have a lot more signal gantries themselves. Started scratch building some of those, but I think this video is getting pretty long now, so I'm probably going to call it done here now that you've actually seen how to go ahead and build up the signal gantry. You've had a look at some of the code that runs the Arduino and that LED driver board. Next video, what I'll probably go over is putting in some of the sensors. So I'm looking at putting in a sensor probably somewhere right around in here, so that as trains on that northbound line are moving south, when they trigger that sensor, assuming they had a green light, they would trigger that sensor, would flip that to red. The idea being that whenever the sensor trips, it would turn to red. So at the moment in its default state of red, if you had a train that was coming northbound as it trips that sensor, it's not going to try and flip it to green, it would stay red. And I'm probably going to do another sensor around here and another one around here. And again, I'm going to assume that these two are almost always going to be southbound lines. So as you would come over here, if you had green, when you trip the sensor, that will go to red, and then that will then start a timer until I would figure in some downstream logic as well. And then this one here, I don't know if I would do downstream, but as soon as you would trip this, assuming it was green, you would trip this, it would then go to red. And once it would run through, it will probably then default back over to that being green. Excuse me. So I'm probably going to leave that for the next video, and also then look at one of the scratch buildings of the other signals here, just so you can see a little bit more of this in action. But at least for now, I think it's pretty cool to see some of the trains lining up and have some signal lights that tell them whether they're able to go or not. So I'll go for a quick clip of one of the trains moving through those signal lights. Hope you've enjoyed this. Let me know what you think. Do subscribe and follow along. If you got any ideas of how we could improve this, please let me know as well. It was great in the last video when I was using the Trendtech signals that I got so many good comments that gave me ideas and point me towards those LED driver boards. So please do let me know what you think. If you got any better ideas, alternative ideas, ways that you go about doing the sensors. I look forward to hearing from you all, and I'll be back pretty soon with kind of part 2, I guess, of this on individual signal lights next to the tracks and some of the sensors.